This recording covers Primary Math 4, challenging word problems. We're picking up on page 19 and going on through page 26. Page 19 starts with number 7, and we have Wendy and Carol who both purchased a laptop, same laptop for the same price. And then we're told that in addition to that, Wendy bought a flash drive, and her flash drive cost $60. Carol bought an infrared mouse, and we have no idea how much the mouse cost, but what we know is that Carol spent $1,810 and Wendy spent $1,840. Now, as often happens, there are key things to look for, and in this case, what we're trying to find, by the way, is the cost of this orange mouse. The difference in the amount they spent is $30. I know that this is the same for both of them. So what that tells me is that this distance, this difference right here, is $30. So if the flash drive cost $60 and she spent $30 less, then she must have spent $30 on the mouse. One of those problems that, because the numbers are so similar, it's almost so easy it's hard. But we begin to see the laptop doesn't matter. The only thing that matters is the fact that Wendy spent $30 more than Carol, but she spent $60 on the flash drive, so it must be that Carol spent $30 on the mouse. And so then, of course, you would go back and say the mouse cost $30 and put it in a nice box, because we're in the habit of answering, making a statement for an answer, and putting it in a box for a good math student. Number 8, a street vendor sells $3 burgers in the morning, $2.50 burgers in the afternoon. On Sunday, the vendor made $120 in the morning. All right, let's pause there. I can find out some information from that. $120 in the morning, selling burgers at $3 a piece. That means that there are 40 burgers. I have to stop, make sure I'm thinking about the right units. $120 earned. I sold them at $3 a piece. That means he sold 40 burgers in the morning. And then in the afternoon, he sold twice as many burgers. And the question is, how much money did he make? Well, in the afternoon, the burgers sold for $2.50 each. 80 burgers times $2 is $160. 50 cents each is another $40. So he earned $200 selling burgers in the afternoon. How much money did he make total? He made $200 in the afternoon, and add that to the $120 in the morning, and we'll know that he earned $320 total on that Sunday. Number 9, we have strings P, Q, and R. String P is 3 times as long as string Q. R is 3 meters longer than half the lengths of strings P and Q. All right, let's think about how to represent that. If I put P and Q together, that would be 4 blocks. R is 3 meters longer than half of it, so half of it is 2 blocks, plus 3 more meters is the length. The total length of all the strings is 5,400 centimeters. What is the length of string R? In order to get this into equal parts, I need to get rid of this extra part on R. But be very careful, that's 3 meters, which is the same thing as 300 centimeters, So to get rid of that, I have to subtract 300, not just 3. That's one of the big things you have to realize, and of course you've got to make sure to pay attention to units in any math problem. So if I have 5,100 centimeters, that is representative of these 6 blocks. So of course I'm going to take 5,100 and I'm going to divide it by 6 and come up with 850. Again, that's 4,800s and 300s. That would give me 240. No, I'm sorry. I can go straight to 300, can't I? That's an even do. So 48 hundreds divided by 6 is 8 hundreds. 30 tens divided by 6 is 5 tens. However you need to think about that or do the math, it comes out to be 850. That is for each of the blocks. The question is simply, always go back and find out your question once you get there, length R. String R is going to be 850 plus 850 plus, don't forget, it's 300. So 850 and 850 is 1,700 plus 300 is 2,000 centimeters, or you might want to say it's 20 meters. I believe the back of the book actually gives both answers as well. It doesn't tell you how to give your units, so either one would be fine, but you do have to keep your units separate and take care of them in this problem. One of the first problems we've had this year in this book that's had different units to deal with. Make sure you handle them appropriately. Number 10. A farmer has twice as many cows as sheep. After he sold 375 cows and another 12 cows died, he had half as many cows as sheep left over. Now, one thing that's important is to think about what is static, meaning what is unchanged, and that is the number of sheep did not change. Okay, so in the end, when I'm finished with my changes, I still have this many sheep. But what I have is half as many cows as sheep. So these cows are all gone. How many cows is that? Well, it's 375 that were sold and 12 that died. So that's 387 cows. Now, notice also we're using the same size blocks, and this is a half of a block. So I could take this whole thing and divide it up into equal parts like this. The ones that were gone represent 3 equal portions of a half of a big blue box, right? They're an orange size. If I take 387 divided by 3, I have 129, and that's what those little orange check marks, orange half boxes represent. The question is how many cows remained, and that actually is one of those check marks. There's 129 cows left. A pretty simple problem that again points out the skill that in a word problem, sometimes you have to think about what doesn't change in order to see, to find the comparison. The fact that the sheep didn't change meant that when there's half as many cows as sheep, that is 1 part here and 3 parts on this side, and those 387 are divided into the 3 parts. Moving to the next section of the challenging problems, page 23, number 1. There are 3 times as many boys and girls in a sports hall. After 75 boys left and 25 girls entered, there were 2 times as many girls as boys. In this case, we do have change on both parts. The boys went down by 75 and the girls went up by 75. I'm sorry, girls went up by 25. And then here's what it tells us. 90 children remained. How many children were there at first? This becomes a simple problem when you realize that the 90 that they tell us are here, and what we're being asked is how many students are here. Now notice, and I should probably do this, let me do this just a little bit differently, because I do not mean to imply that the boxes, the green boxes, are the same. So let me use triangles. Doesn't matter. The point is that the shape is there are twice as many girls as boys. And so because there's 3 groups and 90 of them, I know that there's 30 boys and 60 girls. And then we can just go backwards. What happened here is that 75 boys left, and I gained 25 girls. So before that happened, I must have had 35 girls, and before I went down to 30 boys, I would have had 105 boys. And the question is, how many children were in the sports hall at first? It would be the 105 boys, the 35 girls, which is 140 children were there at first. Number 2 is another one of those problems that we need to understand, and then you just kind of either figure it out or you take a long time to figure it out. If you take 3 whole numbers and you add them together, you get the same thing as their product. Product means multiplication. And so what is that number going to be? Well, we could do a little bit of guess and check. If I did 2 plus 3 plus 4, that's equal to 10. But 2 times 3 times 4 is equal to 24. You see that it gets big really fast. And you realize, wow, I can't go that big because I'm going to far outdistance myself. I mean, think about 10 plus 11 plus 12. You're going to be in the 30s, and your multiplication number is going to be in the thousands. So we have to keep really small, and what we actually find is one option is 1 plus 2 plus 3 is 6, and 1 times 2 times 3 is also 6. The question is, what are the numbers? Using guess and check, we found that 1, 2, and 3 is a set of numbers that work, and we found one. Number 3, the product of 2 whole numbers is 10,000. Neither number contains a 0. How can that be? Because we could do 100 times 100, but those both contain zeros. How are we going to find that? And the hint tells you think of multiples of 10. I guess that's what they mean. I like to use a factor tree. 100 or 10,000 is 100 times 100. Notice I just divide out the zeros. There are 4 zeros, so 100 times 100 is 10,000. And then of course I know that 100, you can do it any way you want to. That's kind of the long way. I also know that 100 is 10 times 10. Here's the point. When you get down to it, 10,000 factors to be 2 times 2 times 2 times 2. Let me mark those up for us. We have 1, 2, 3, 4 2s, and we have 4 5s. And when I multiply all of those together, when you multiply all that together, of course, you are going to get 10,000. But one way to look at the factors, the numbers that multiply together to get this, is to never combine the 2's and the 5's. If you multiply 2 and a 5, you're going to get a 10, and that's going to give you a 0 at the end. No matter what you do, 10 times anything is always going to be a 0. But if you break it down like this, you can find the prime factors, and then you can never put a 2 and 10 together, never end up with a 10, never have a 0. 16 times 625 gives you the answer it's looking for. Number 4, Belinda is 7 years older than her brother. Belinda and her brother. Three years ago, their total age was 43. Now, again, what is static? What is not changing? This value doesn't change. So 3 years ago, their sum was 43. Belinda was still 7 years older than her brother even then. So we could subtract the 7 from 43 and find that that's 36. And if we divide that by 2 and get 18, then we find that 3 years ago, the brother was 18 and Belinda must have been 25 because she was 7 years older. The question is, what will be Belinda's age in 12 years from now? Well, if Belinda was 25 3 years ago, then I would add 3 to get her current age, and I would add 12 more to find out how old she'll be then. And what we find out is that she will be 40 years old 12 years from now. We're just handling the amount. Now, another thing that occurred to me after I worked this is method 1. Another thing we could do is say, you know what, 3 years ago their combined age was 43. So now in 3 years, they've each aged 3 years, so that would mean I would add 6. And in 12 more years, they would add 24. And so by then, their combined age is equal to 66. I'm sorry, 73. Got ahead of myself on my notes. These numbers add up to 73. If I subtract, then I kind of go back to this. If I subtract those 7 years that Belinda had older than her brother, then I could get that back to 66. Divided by 2 is 33, and her brother is 33, and Belinda is 40. I could also go back to that point and say if the combined age is 73, instead of subtracting 7 and getting the brother's age, I could add 7. If I add 7 to get 80, and I divide by 2, then that gives me Belinda's age, right? Instead of subtracting 7, if I just add 7 to brother, then what I've done is make Belinda's age my baseline. And so when I divide by 2, I get Belinda's age. So that's kind of sort of 3 ways to solve the problem. All of them give the same answer, which is really convenient. It makes me pretty confident that I got it correct. Number 5. Peter and Lillian spent a total of $78, and Lillian and Adam spent a total of $124. And then here's the key. We know that Adam spent 3 times as much as Peter. So Peter's my baseline. Adam spent 3 times as much as that. And I don't know what Lillian spent, so I'm going to make her a circle. I don't want to, if I make a box, I don't know if the box is bigger or smaller. I'm just going to use a different shape. You could use a triangle, it doesn't matter. Some shape is what Lillian has. I know that Peter and Lillian spent 78. I know that Lillian and Adam spent 124. And again, we've done this kind of problem before. The difference in what they spent is that Peter spent 1 and Adam spent 3. And so the difference in these numbers, again, mental math, 78 goes to 100 by adding 12. I need 24 more than that, so that's a difference of, sorry, that's 22, and 24 is going to be 46. is the difference between them, and that difference is these two boxes. So the question is, how much more did Adam spend than Peter? And that question is really easy. He spent $46 more. And then part B wants to know, how much did Lillian spend? If each of the boxes is 46, then 78 minus 46 is going to be $32. I'm sorry, no. Hold on. Each of the boxes is 23. The two boxes is 46, so this one is 23. So 78 minus 23 is $55. And so that's what Lillian spent. Again, I would strongly recommend that you just pause a minute and ask yourself if all the numbers make sense. Peter and Lillian, if you combine these, do spend $78. If this is 46 and 23, then altogether, what's the name? Adam spent $69. And 69 and 55 do add up to 124. And 23 tripled is 69, so Adam did spend 3 times as much as Peter, and so that gives me confidence that my answers are correct. In these problems, they go from, sometimes they get complicated and then you get some easy ones. Number 6 is a really simple one. I always encourage my children to, keep going. Don't stop just because you find one to be hard. Try the next one, because it may be that that's a really easy one. Number 6, a tall glass can hold 750 milliliters of water. A bottle can hold twice as much water as a glass. So that's 1,500 milliliters of water. And a jug can hold 4 times as much as the bottle. 4 times 15 is 60, so that's 6,000 milliliters. What is the capacity of 3 bottles and 4 jugs? Well, 3 bottles would be 4,500 milliliters, and 3 jugs would be 2,400 milliliters. I'm sorry, 24,000 milliliters, which altogether would give me 28,500. And I'm using the word milliliters. It's listed as cubic centimeters. Maybe you know this, maybe you don't. The definition of a milliliter is if you took a centimeter cube, right, like just a little cube of a centimeter, and you filled it with water, that's how much a milliliter is. By definition, if you took a little box that was 1 centimeter by 1 centimeter by 1 centimeter, and you fill it with water, that's how many milliliters it is. So when it says cubic centimeters and I say a milliliter, I apologize for that, but it is exactly the same thing. Now, that's kind of the math way. I think that they put this in here because there's kind of a smart way to do it, so to speak. If a glass can hold 1, and a bottle holds 2, and a jug holds 4, then if you do 3 bottles, that's 6 boxes. And if you do 4 jugs, that's 16. And so the other way to think about this, instead of finding all the values, I could have just said 22 times 750. 2 times 750 is 1,500, so 20 times it is 15,000. Sorry, I'm about to get myself in trouble here. I knew there was something wrong. I had to pause and find it. The jug holds 4 times as much as the bottle, so actually the jug is going to be 8 boxes. And if I find 4 jugs, then 8 times 4 is 32, which doesn't give me 22, it gives me 38. So if you do 38 times 750, you'll end up with the same amount, 28,500. I'm not sure that that's necessarily any easier, but it is another way to do the problem. I kind of got a little garbled over here. So actually the second way to work the problem is split up on this page. There. That's the second way to work it. If you just, instead of going to milliliters or cubic centimeters, and you take how many groups do you have, and you find that altogether there are 38 groups, each group being 750 cubic centimeters, then you come up with the answer of 28,500 cubic centimeters, or milliliters. Tom had $190 and Jane had $60. And then each of them received some money from their father. So we'll just make it a bag of money. What we know is that it's an equal amount from their father. And after they received that, then Tom had twice as much money as Jane. How much did the father give them? At first it looks too hard to do. Again, please remember what did not change, and that is that the difference between them is $130. If Tom has $130 more than Jane in the beginning, then Tom is going to have $130 more than Jane in the end. If he has $130 more than Jane in the end, then he must have $260 and she must have $130. If she started with $60 and ended with $130, then she must have been given $70. If he started with $190 and went to $260, he must have been given $70. How much did the father give them? The father gave $70. I think it's amazing how a problem looks like it's going to be very difficult, and one little bitty fact that is obvious, staring you in the face, but it's not easy, but it makes the problem a simple one to solve. Number 8, going to take a chart. Lots of times when it requires a table, I organize my data this way. I know that an adult ticket costs $10, a child ticket costs $7, and Mr. Sullivan buys 13 tickets total. For $106. So I'm trying to figure out how that's going to go, and I might just start with 6 adult tickets and 7 child tickets. The adult tickets would then cost $60, and then child tickets would cost $49, and that would be a total of $109. That's too much money because I'm aiming at $106, so I need to buy fewer adult tickets and more children's tickets. I had to have the same number of tickets. So the 13 tickets has to be the same, but I need to buy fewer expensive tickets in order to lower my price. So 5 adult tickets would cost $50, 8 child tickets would be $56, and it's a really pretty short and painless guess and check when you can get it that fast. The question is, how many child tickets did they buy? And they bought 8 child tickets. Number 9, there are twice as many cows as goats on a farm. All the cows and goats have a total of 108 legs. And the question is, how many cows are there? We could solve this with a guess and check box. I want to introduce another method. Probably you know how to do the guess and check boxes. We've done that a lot. Here's what I want you to notice. I'm going to take all the cows on the farm and I'm going to group them into groups. And I know that every group is going to have 2 cows for every 1 goat. That's what I mean by having twice as many cows as goats on the farm. And so what I don't know is how many of these I have. I have a bunch of sets, but I don't know how many. But here's something else I know. Each of my sets is going to have 12 legs. Cows have 4 legs, goats have 4 legs. Every one of my sets has 12 legs. And I know there's 108 legs in the entire farm. Now, this is an odd way to word a problem, and it certainly could be figured out easier by counting cows instead of counting legs, but let's just go with it. Acknowledge that. Your child's going to tell you, my children all told me, but we're just going to go with it. If there's 108 divided by 12, that is equal to 9. What that tells me is that there are 9 sets of 12 legs, which tells me there's 9 of these boxes. Each box has 2 cows. 9 times 2 is 18 cows. Now, another thing you could do that's also pretty simple is to say, if I have 108 legs, since every animal does in fact have 4 legs, then I can do that and find that there are 27 animals. And if the cows and the goats, if there's twice as many cows as goats and there's 27 animals, then I know there must be 9 goats and 18 cows. And that's a great way to work this problem, but I prefer that first way because we're about to do a problem number 10 when the number of goats and the number of legs are not the same on each animal, and the first method works for that. The orange method works simply because every animal has 4 legs. Number 10. There are 3 times as many chickens as goats on a farm, and all the chicken and goats have a total of 2,400 legs. So again, if I group my animals in sets, and I don't know how many sets I'm going to have, but I know that there are 3 times as many chickens as goats. So every one of my groups of animals is going to have 3 chickens and a goat. And I don't know how many there are in the middle here, but I have a bunch of them. Each of these groups, and here's the key to realize, all the animals have to fit evenly into one of these sets. Okay, I can't have 15 sets and 2 extra goats because I have a ratio of 3 chickens for every 1 goat. They have to fit evenly in that. And I know that in any one set, isn't this nice, I have 10 legs. 4 goat legs, 6 chicken legs, gives me 10 legs altogether. So if I have 2,400 legs and I divide it into 10, then I know that I have 240 sets of animals. See how easy that becomes when we organize it? It's all in how you're organizing it. So then how many more chickens than goats are there? Well, there's 240 sets of animals, and every animal has 2 more, every set has 2 more chickens and goats. You could just say 480 more by looking at it because, again, every set, the chicken and goats are equal, and every set has 2 more chickens. So if there's 240 sets, there's 480 more. You could certainly take one more step about that and say, okay, 240 sets means there's 240 goats. There's 3 of those, 720 chickens. And so how many more are there? There's 480 more chickens than goats. All right, and that is the last problem in this recording.